Okay, so let's set a scene. You're at home, right? Your phone's on the Wi-Fi, your laptop is chugging away on an update, and your smart TV is queuing up your next binge watch. All these devices are chatting with your router at the exact same time. So, how in the world do they keep all those conversations straight?
Seriously, think about it for a second. When you hit play on Netflix, how does that stream of data, that movie, find its way from the internet, through your router, and land on that one specific screen? How does it know not to go to your printer instead? It kind of feels like magic, doesn't it? Well, it's not magic, and the answer is one of the most fundamental ideas in all of networking.
You see, without some kind of system, your home network would be in a constant state of chaos, a total identity crisis. Sending data would be like trying to deliver mail in a giant apartment building where none of the doors have numbers. The mail might get to the right building, that's your home network, but after that, it would just be lost, bouncing around with no clue where to go.
To solve this exact problem, every single device that can connect to a network gets something special the moment it's manufactured. It's given a permanent, unchangeable digital fingerprint. This little fingerprint guarantees that no matter how crowded your Wi-Fi gets, every bit of data knows exactly which device it's supposed to be talking to. And we call that fingerprint a MAC address.
So, what exactly is this digital fingerprint? Let's pull it apart and really look at what makes it tick and why it's so crucial for getting that movie to your TV.
So MAC stands for Media Access Control Address, and the two most important words there are permanent and hardware. This isn't some temporary number that your router just makes up. No, this address is physically burned into the network chip of your phone, your laptop, your smart TV, you name it. It's a core part of its physical being.
And these addresses have a really clever structure. It's a string of letters and numbers, but it's not random at all. Let's look at this example. The first half, that A46B12, basically tells you who made the device. It's a code assigned to a specific manufacturer, like Apple or Samsung or Intel. Then the second half, the 9F3388, is like a unique serial number that the manufacturer assigns to that one specific chip. You put them together and you get a globally unique ID.
And because of that brilliant system, combining the maker's ID with a unique device ID, we get to this fundamental rule of networking. In theory, no two devices on planet Earth should ever have the same MAC address. It's designed from the ground up to be a one-of-a-kind identifier, which is exactly what makes it so powerful and reliable. Okay, so every device has this unique name. But how does your network actually use it to direct all that traffic? Well, for that, we need to talk about the unsung hero of your home network, the network switch, which is usually built right into your Wi-Fi router. Just think of the switch as a super smart, incredibly efficient traffic cop.
Here's how that traffic cop does its job. The first time your laptop sends anything out over the network, the switch is watching. It sees the data come in on, say, port number 3. It instantly reads your laptop's MAC address from that data and makes a little note to itself. It builds a table that says, hey, this MAC address lives at port 3. From that moment on, any data that's addressed to your laptop gets sent directly to port 3 and nowhere else. It's fast and incredibly efficient.
Now, this is a really, really key detail to remember. This whole conversation, all this chatting using MAC addresses, it only happens inside your local network. Between all the devices connected to your home router. Your MAC address is for local gossip only. It never, ever goes out onto the public internet.
And that idea that a MAC address is strictly local brings us to probably the biggest point of confusion for people learning about networking. What's the difference between a MAC address and an IP address? They both sound like addresses, right? But they play completely different roles. Let's settle this once and for all.
This chart really breaks it down perfectly. The best analogy is this. A MAC address is like your name. It's permanent. It's part of who you are. An IP address, on the other hand, is like your hotel room number. It tells people where you are right now, but tomorrow you might be in a different room or a different hotel altogether. Your MAC is for that local room-to-room communication, while your IP address is for getting mail delivered to the right hotel from anywhere in the world.
All right, so that's the techie stuff, but why should you care? Why does any of this actually matter in your day-to-day life? Well, the simple answer is that without the MAC address, your digital life just wouldn't work. Think about it. Every single time you connect your phone to Wi-Fi, your router is checking its MAC address. When you hit print on a document, your computer finds the printer on your local network using its unique MAC address. And yeah, when you're streaming that movie, the final handoff from your router to your TV, that's all handled by the MAC address. It's even used for security, letting you create guest lists for your network, only allowing certain devices to connect.
So here's the big takeaway. The MAC address is this silent, invisible workhorse. It's the absolute bedrock, the fundamental building block that all of our local communication is built on. It's this simple, elegant system of permanent fingerprints that allows our incredibly complex digital world to run so smoothly.
And that leaves us with one last, kind of important question to think about. If every single device we own has a permanent, unique fingerprint that it's constantly broadcasting, well, what does that mean for our digital privacy? It's definitely something to chew on. Thanks for tuning into this explainer.